All right. So for a function to have an inverse, right? For a function to have an inverse, right? It must be bijective, right? What does bijective mean again? It means that it's both one-to-one or injective. It's both injective and surjective. Okay? So you have to show that it's both of them before you can find the inverse, right? What's the geometric relationships between the inverse and f of x? If I give you a function and the function is f of x, then its inverse is the reflection in the line y equal to x. So f inverse x is the reflection of f of x in the line y equal to x. All right. Anybody remember this? What is f of f inverse x? Or what is f inverse of f of x? But what's the general answer? So think about this, right? Think about this, right? Suppose I gave you this relationship here. Suppose I gave you the relationship between x and f of x, right? Let's call that y actually. Let's call this y, right? And to go from here to here, we need a function f of x. Then what is the mapping from here to here? How do I map all the y values to all the x values? F inverse x, right? In fact, let me give you the word in here. This is your domain. It says your range, right? Let's do codomain actually. What is the domain of the f inverse x? Right, so the domain of f inverse x is the codomain of f of x, right? That makes sense? The y values. So the x values of f inverse is the y values. All right? So the domain of f inverse x is the codomain of f of x. Right? And the codomain of f inverse x is the domain of f of x. So take a look at the red part underneath. Right? Let's pretend I gave you a function. F of x is x plus 1, right? And I wanted to get the image of 2. What's the image of 2? 3. Right? So that'll be 2 plus 1, which is 3. But suppose to go to the next relation now, I needed to get f inverse x. F inverse x is what? You can do that mentally in your head. X minus 1, right? That's okay? Right. Nice. So what will 3 be mapped to? 3 will be mapped back to 2. You're seeing that? Suppose I had 4. 4 will be mapped to what? 5 will be mapped to what? Are you okay with that? Yeah? So let's go generally. X is mapped to what? X plus 1, right? So x plus 1 is mapped to what? X. That's okay? X plus 1 minus 1 given impact x. So what is f inverse of f of x? Every time you find f inverse of f of x, you're getting back what? You're getting back x. You're getting back x, what you originally had, right? So if I say, here's what? You have f of 2, what is the inverse of f of 2? You will always get back 2. Suppose I go the other way around. Suppose I gave you f inverse and I want to go here and then here. It'll be the same thing. Okay? So it means that f of f inverse x is also x. So we did two things there. We discovered this relationship and we also introduced composite functions. A function of a function. So if I ask you to draw the relation diagram for a composite function, it looks like that. By the way, to have this part here, so I'm taking that off, right? So basically, you could go back to the first part of your notes. I'll come back here just now and write x on the end. F of f inverse x is equal to f inverse f of x, which is equal to x. Copy down the example in red to explain where it came from, right? Okay, so that's a rule for us to remember whenever you see this, right? Right, how do we find the inverse again? Right, first thing is what? Let's y equal to, and then interchange x and y, and then solve for y. All right, so basically what you're doing is you originally had y equal to x. You're trying to get an equation x equal to y, and that'll be the inverse relationship. All right, so those are your 4 steps. Let's just do a in between. I'm giving you a medium here, right? Try this, please. Same thing for maths. Find the inverse there. 3x minus 1 and 2. Right, so you should let y equal to f of x. So y is equal to 3x minus 1 over 2. Then we're going to interchange x and y. So x is equal to 2y minus 1 on 2. Oh, sorry. 3y minus 1 over 2. And then we're going to solve for y. I'll squeeze it in right here. Cross multiply one time, you'll get 3y minus 1 is 2x. 3y is 2x plus 1. Or y is equal to 2x plus 1 divided by 3. Okay? So that is your inverse. 2x plus 1 over 3. And remember, graphically, the inverse is a reflection in the line y equal to x. How you obtain now? Remember that? If I give you a function and you have to reflect it in the line y equal to x, what is change? So suppose I give you something like this. What's a reflection of minus 3, 5? 5 minus 3, right? Right? Switch the x and the y. So it will be like 5 minus 3. Okay? Well, a little closer, of course. Let's remember that, right? So reflect in the line y equal to x, switch the x and y values. Okay, so that's the theory behind it. We'll do some past papers just now on this. Before we do that, let me just run over what's a composite function. Composite functions, right? Right, so these are functions. Right, these are functions that consist of 2 or more functions, right? Right, for now, we'll be just doing 2 functions. Right, so for example, if I give you this f of g of x, that's a composite function, right? What does this mean in words? So this is saying that g of x into f of x. Similarly here, f of x into g of x. What about f squared? What does that mean? So f squared means f of x. All right, let's start here. This is June 2014, number 2A, right? So part 1, they want you to find f of x. So f of, open brackets, are replacing f of x with 2x squared plus 1. And then I'm going to put 2x squared plus 1 right in there. So I'll have 2 open brackets, 2x squared plus 1, all squared plus 1. When you square it out, you will get 4x to the 4th plus 4x squared plus 1 plus 1. So you'll get 8x to the 4th plus 8x squared plus 3. So that's it, f squared, right? And part B, you want it f of g of x. So f of g of x is the square root of x minus 1 and 2. So you're going to put the square root of x minus 1 and 2, same thing, right in there. Remember, g going into f. So it will be 2 by the square root of x minus 1 and 2 squared plus 1. So you're going to square the square roots. That'll cancel off. And then 2 by 2 is, that'll cancel as well. And you'll get x minus 1 plus 1 is x. What does that mean? It means that g of x must be the inverse. All right, next one. Next one is 2013, number 2A and B. Right, before you try to use f of A equal to f of B, then we have to show A equal to B if it's 1 to 1, right? Yeah, if they don't state what method to use, you can use anything you want. So because the mathematical was tricky, I find the graph would have been easy, right? But mathematically, here's what you have to do. You have to take this and complete the square. Put it in the form a by x plus a squared plus k. Because what you see, you'll end up with a squared minus a is b squared minus b. What are you going to do? Okay, well, I'm going to do it, right? A is how much here? A is 1. And b is minus 1 and c is 0. Okay? H is b on 2a. So that'll be minus 1 and 2. So b is minus a half. And k is c minus a squared. C is 0, a is 1, and h is minus a half squared. So I got minus a quarter. So f of x is really 1 by x minus a half squared minus a quarter. So now we could find f of a. F of a is a minus a half squared minus a quarter. And f of b is b minus a half squared minus a quarter. Now we could use it, right? And see what will happen. Right, so the quarters will cancel and you'll get a minus a half squared is equal to b minus a half squared. And then you'll square both sides. So you'll get a minus a half, b minus a half, and then the half will cancel. So you'll get a equal to b. One thing I want you to remember, whenever you have the square root of something, remember it's plus and minus. Huh? So it's plus and minus b minus a half. Right? Plus and minus b minus a half. So really and truly, there's something I kind of left out here. But let me show you why I left it out, right? When you work this out again, a minus a half is plus and minus b minus a half. So plus and minus means you're doing it twice. A minus a half is equal to b minus a half. That's when it's plus, and a equal to be. But when it's minus, you're going to get a minus a half is equal to minus b by a half. But based on the rules here, based on the domain given, can the values be negative? So you could say that this here does not exist. Because of the domain, all your values are more than 1. So therefore, it implies that that right-hand side does not exist. All right, that's the mathematical way. The easier way for this question, the easier method for this would have been graphical. Graphically, f of x is equal to x squared minus x is a what? It's a quadratic, right? What are the x-intercepts? Solve x squared minus x equal to 0, and you'll get x by x minus 1. So you'll get x is 1 and x is 0. X-intercepts are x is 1 and 0, and the y-intercept, there's no y-intercept, right? So that's 0. So this sketch will look something like this. But question says that you only want a domain for x is more than 1. So you could ignore this part of the graph. Okay? So your graph will look like this here. And then you can do the horizontal line test. Draw a horizontal line, it'll only cut once. Therefore, it's 1 to 1. So once you remember how to sketch a quadratic, a sketch would have been much easier than the next method. Okay, finish the last part for me now, please. What shall we got for f inverse x? X minus 2 and 3. And then g, in fact, let me just do g inverse. Y is equal to e to the 2x. So x is equal to e to the 2y. Then what you'll do? Take ln on both sides. Ln e will cancel off. Ln e is 1. So you'll get ln x is 2y. Y is equal to ln x on 2. Okay, or you can write it like this. A half ln x. Or if you want to look real smart, you can write it like this. Ln square root of x. So remember that? Power rule. Bring the half and put it on top here, right? All you have to do now is find f of g of x. Right, so f of g of x is what? F of, open brackets, e to the power of 2x. So you're going to put e to the 2x in f of x. So that'll be 3e to the 2x plus 2. In 2018, they started to ask questions looking like this, right? So take a look at that question. I want you to tell me how we could find the inverse. Yes, catch the inverse and use a graphical method to show it by objective. Right here, anybody remember one line? So you're drawing the line y equal to x and you're going to reflect it, right? So draw the line y equal to, it has to be exact here earlier. The line y equal to x will pass through 1, 1, 2, 2, 10, 10. Okay? So make sure you draw that line perfectly. And then pick up your coordinates and switch it. For example, right, yes. Yeah, so when you're reflecting the line y equal to x. One of the points is 2, 8. So instead of 2, 8, you're going to plot 8, 2. So 8, 2 will be somewhere here. Right? Our next point would have been 0, 0. Our next point would have been 1, 1, 4. 1, 4 becomes 4, 1. Right? And you just smoothen it out. Right? So your reflection looks something like that. Right? It's not the best looking thing there, but you all follow what I did? Right? How you're going to show that it's bijective? Horizontal line test, and you can do the vertical line as well. So you're drawing a horizontal line and showing that the function 1 to 1. I join a vertical line as well and say, since it passed both the horizontal and vertical line test, the function is both surjective and injective. Sketching is the most important thing. Once you can sketch, these questions become easy.